Hello, welcome back to our intermediate algebra course, and today we will talk about section 7.5, rationalizing denominators and numerators. But first, as usual, think about the puzzle. The question today is, if you drop a coin from the roof of the Empire State Building, it's a very tall building, 1,296 feet high, how long will it take for the coin to hit the ground? Be careful, don't let the coin fall on a person that's walking by because they say it's very dangerous. It can hurt the person that's walking underneath on the sidewalk. Okay, so what do you think? It will take a few minutes, maybe, or not that much, maybe several seconds. What do you think? How long will it take for the coin to hit the ground? Well, this is kind of a very tricky question, very hard question to answer. And the hint is you're going to need a formula. Later we will work together. So guess, try to find out by guessing, because now we will talk about rationalizing denominators. And this is something that eventually is useful to rationalize the denominator, so we don't have any radicals on the denominator. Look at this example. I want to get rid of the square root on the denominator, so we don't want square root of 2, we want something else. We have to find a way. What we can do is multiply the top and the bottom by the same number. We have to find a number that will cancel out, will remove the radical from the denominator. Can you think which number is this that you have to multiply the top and the bottom? We don't change when we multiply by the same number on the top, on the bottom. We don't change the ratio, the fraction. So think what kind of number is this? Yes, look, think. If you multiply square root of 2 times square root of 2, you have square root of 2 times 2 is square root of 4, and this is, we know square root of 4 is 2. That is the right answer. You have to multiply on the bottom by square root of 2 and on the top as well, so we don't change the ratio. That means this is equals. Square root of 2 times square root of 2 is 2. And square root of 3 times square root of 2, square root of 3 times 2, square root of 6 over 2. That's going to be the final answer. Look, it's the same ratio, the same fraction, but with no radical on the denominator. Another example. Rationalize the denominator. We have square root of 2 over 45x. We can write this as square root of 2 over square root of 45x, right? And we don't want the square root on the denominator. So multiply, yes, I know what you think. You can multiply both the top and the bottom by square root of 45x. And it will work, but the problem here is we need later to simplify, because this will be like a large number. The best thing right now is, first, before you try to rationalize, check if you can simplify this denominator. We can write square root of 2 over square root of 9 times 5x, right? 9 times 5 is 45, and 9 is a perfect square. That means this is equal to square root of 2 over square root of 9 times the square root of 5x, and we know square root of 9. This is equals square root of 2 over 3 square root of 5x. Now we will rationalize. After simplifying, we rationalize by multiplying both the numerator and denominator by square root of 5x, and not square root of 45x. Will be more trouble to simplify. Multiply square root of 2 times square root of 5x, square root of 2 times 5x over, just over 3, and square root of 5x times square root of 5x is 5x. This is square root of 10x over 15x. That's the final answer. Okay, next example. Rationalize the denominator. We don't want a cube. Now it's a cube root. Now we have a cube root. We can write this as cube root of 2 over cube root of 25. Right? We don't want this cube root of 25 on the denominator. We want to rationalize, so we can multiply. But look, now is cube root. The index is 3. The index is 3. We need to find a number that if you multiply on the top, on the bottom, you're going to be able to cancel the cube root. And that means we have to find a way of getting a perfect cube here on the denominator, right? Look, 25 is 5 squared, right? So we have here on the denominator cube root of cube root of 5 squared. We need to increase this power to have a cube. This solution, the best solution, is to multiply by cube root of 5 to the power of 1. Because then you will have cube root 5 squared times 5, and that's cube root of 5 cubed equals 5. Okay, makes sense? All right, now multiply both the top and the bottom by cube root of 5, cube root of 5. Always multiply by the same number, the top and the bottom, so you don't change the fraction. Let me just fix this. Yeah, nicer. And cube root of 2 times 5 on the top, and cube root 25 times 5 is 125, right? But that's the same thing as 5 cubed. And this is equals cube root of 10 over, oops, no more, we rationalized, we don't have any roots anymore on the denominator, over 5. That is the final answer. Another example. Now we have letters, we have variables. Rationalize the denominator. We can break down, this is square root of 7x over square root of 3y. Just multiply. We want to get rid of this square root of 3y. Multiply both the numerator and denominator by square root of 3y. On the top, on the bottom, we will remove the square roots. On the top, we have square root of 7x times 3y. And this is equals the square root of 21xy over 3y. That is going to be the final answer. Okay, if we have just one term on the denominator, it's kind of easy. We just find a number that multiplied will remove the root, right? We'll have here in this case, if the index is 2, is a square root, we're just going to have 3y times 3y squared, and we'll cancel out the root. But what about if we have two terms? Let's see an example. I want to rationalize the denominator, but now we have on the bottom 2 plus square root of 7. We will actually use some knowledge that we have about formulas, special products. Remember this formula: a squared minus b squared equals a plus b times a minus b. This is difference of two squares, and we know this is a special product. We can use this formula to help us. Let's make 2 is going to be a, and square root of 7 is going to be b. If we have a equals 2 and b equals square root of 7, then this is equals to a squared is going to be 2 squared, minus b squared, square root of 7 squared. And this is nice because, okay, 2 squared is 4, and square root of 7 squared, this will cancel out. Look. Right, 4 minus 7 equals negative 3. Because 2 minus square root of 7 is the conjugate of 2 plus square root of 7. Okay, multiply both the bottom and the top by the conjugate, and then we will have, don't need to apply right now distributive property. Let's check if we can simplify later. 2 minus square root of 7, let's keep it like that. On the bottom, we will have 2 squared minus square root of 7 squared. You've seen here, right? And this is equals 3, 2 minus square root of 7 over negative 3. And that's interesting because we can simplify. Look, 3 divided by 3, 1, and we still have the negative, right? So that's going to be equals to negative 2 plus, since we have negative, this becomes negative 2, and this becomes positive square root of 7. That's going to be the final answer. Okay, let's check another example because this conjugate is a bit tricky. Let's have a look at another example. Rationalize the denominator. We have two terms on the denominator, and we're going to do the same thing as before. Multiply the denominator and the numerator by the conjugate. And the conjugate, if here we have plus, the conjugate is going to be with minus. Square root of 2 minus square root of 3. On the top, the same thing, square root of 2 minus square root of 3. And this is equals. Just keep it for now. Okay, repeat everything on the top. Don't worry too much about the top right now. Let's look at the bottom. Square root of 2 is squared minus, that's the formula, square root of 3 is squared. This is equals. Okay. Square root of 3 plus 2. I was still repeating this over square root of 2 squared is 2. Square root of 3 squared is 3. 2 minus 3, so negative square root of 3 plus 2 is square root of 2 minus square root of 3. Look at your answer so far. We have this answer, and this probably is the final answer. Can we simplify any further, any more, this final answer? What do you think? Look at this factor. This factor it looks kind of similar, but is actually different. We have plus, we have minus, and we have 2, and we have square root of 2. We cannot simplify this any further. The final answer will be negative square root of 3 plus 2 times square root of 2 minus square root of 3. That's going to be the final answer because you actually cannot simplify any further. Let's talk now about rationalizing the numerator. We've been working to rationalize the denominator, the bottom. Now we can we will work the same thing, but with the numerator, with the top. That means this is rationalizing the numerator. Look at this example, square root of 12 over 7. We can break down, this is equals to square root of 12 over square root of 7. We want to remove the square root from the top. First, before you try to multiply, check if you can simplify the square root of 12, because we can write as the square root of 4 times 3 over square root of 7, and the square root of 4 is 2, right? So 2 square root of 3 over square root of 7. We need to remove now the square root of 3 from the top. Multiply both the top and the bottom by square root of 3, and then you have 2 times square root of 3 times square root of 3 is 3 over square root of 7 times 3 on the bottom. That's 6 over square root of 21. That's the final answer. As you can see, rationalizing the numerator is the same method, the same step-by-step as rationalizing the denominator. The only difference is that you're going to be working with the top of the fraction and not the bottom of the fraction. But it's basically the same step-by-step. And to be honest, it's much more common to find questions asking you to rationalize the denominator. It's not usual to ask you to rationalize the numerator. But you know how to do, you know how to work it out. Let's skip this. Let's say this question, this example. Rationalize the numerator. The numerator is the top, right? The numerator is the top. So we have to rationalize, remove the radical from the top, the radicals in this case. Same thing as before, we're going to multiply by the conjugate. And the conjugate, since this is plus, is going to be minus square root of x minus square root of y. See? Multiply the same thing on the bottom, square root of x minus square root of y. And this multiplication on the top, you're going to have, by the formula, square root of x square minus square root of y square. And on the bottom, look, they are the same, right? We have the same factors, so we can write square root of x minus square root of y squared. This is equals, on the top, x minus y over square root of x minus square root of y squared. This is the final answer. We cannot simplify any further, so this is the final. So what are your guesses? How many minutes, or just a few minutes, or less than 1 minute, or several seconds, or just a few seconds? What do you think? You're gonna be guessing, right? To find the right answer, you need a formula. And the formula I will give you is the high over 16. If you find the square root of high over 16, this is going to be equals to the time in seconds. The high, 1,296 divided by 16. Find the square root. Oops. This is going to be square root of 81. And square root of 81, 9 seconds. 9 seconds is the right answer. Just 9 seconds. Not several seconds, not several minutes, just 5 seconds. And I think it's a myth that the coin will hurt someone in the sidewalk. I don't think this will happen. Thank you for watching. I hope to see you again on the next meeting.